SQL and Spanner accessed over HTTPS using some API? Yes, you can. I just found the link for the Cloud Spanner API for you. Sorry, that's the wrong link. This is okay. The link that I have pasted in is to my crash course for the professional data engineer. A couple of questions came in about that. That's the link here. The link for the Cloud Spanner API is here. You can see the REST API that all GCP services will have a REST API that you can use to access. So PK, hopefully I already answered your question, which said does Spanner support all three databases? It's not Spanner that supports that. It's Cloud SQL that supports that. And does Snowflake use Cloud Spanner underneath? Snowflake and GCP's BigQuery are rivals. Snowflake uses its own SQL query engine. They have developed their own proprietary technology. They do not use Cloud Spanner under the hood. They are their own. They are a separate company, and they're rivals with Google's BigQuery. I think. There's a question here. It's an excellent question. How does cost get calculated for BigQuery if it is serverless? It's a very, very good question. You are billed based on how much data you store in BigQuery, and let me just look at the answers that came in. You're billed based on how much data you store in BigQuery and how much processing you perform. So when you run a SQL query, some data will be processed, right? What is the amount of data that is processed per SQL query? You're billed based on that. So processing and data storage. All right, I'm going to look at the responses that have come in. Cloud SQL is absolutely the right answer. Next question on storage use cases. Everything going well so far? Anything that you guys haven't understood? It's a good time to ask while the polls are going on. Please, if everything is going well, just say, all good so far, or all clear, or yes, going well, something like that. Just so I know that we're all on the same page. Thank you, CA. I appreciate it. Thank you, AM. HA. Thank you. Great. I'm glad. Yes. All right. 5 more seconds and we move on to the next poll. Let's go on. Cloud Spanner is absolutely correct. You do not get transaction support with BigQuery. So Cloud Spanner is the answer here. Okay. Next question. Building a chat application and you want real-time message updates. So SP, I was just looking for the right link to answer your question. So persistent disks can also be boot disks, right? So they have the boot sequence, they have the boot OS. in order to create a virtual machine from a snapshot, you have to snapshot the boot disk. So it so here you can see how you can create a snapshot and then create a virtual machine instance from that snapshot. And then, of course, if you have a virtual machine instance, you can use that to create a virtual machine image. I'm going to look at the responses here. And Cloud Firestore is absolutely correct. That's the real-time database part of the Firebase platform. Next question. Last poll question before we move on to networking. I do not have a session on GCP security. The GCP courses I run are GCP Cloud Fundamentals, where I kind of teach the basics of the GCP. That's a hands-on course where I do demos. Then I teach this Professional Cloud Architect Certification Crash Course and the Professional Cloud Data Engineer Certification Crash Course. Those are the 3 GCP courses I have on O'Reilly. Five more seconds. All right, let's take a look at the responses. And Cloud Big Table is correct. 71% of you got it right. Let's move on. Let's talk about networking on the GCP. And here is where I believe GCP is significantly different from AWS. Unfortunately, I've not worked with Azure networking, so I can't speak to how different it is from Azure networking. But GCP's networking is different from AWS, and we'll discuss that here. Now, what is networking, right? You have IP addresses associated with virtual machines. If you send data from one machine to another, it needs to have some way of finding the other machine. This is done via routes. Okay. You need to have a way of indicating what traffic is allowed on this network and what traffic is not allowed. All of these IP addresses, routes, and firewall rules all exist inside a GCP resource called a VPC network, Virtual Private Cloud Network. Okay. So what is Google's Virtual Private Cloud, or VPC? Okay. Now, there are many terms for it. You can just call it network, you can just call it VPC or VPC network. So I'll use the term VPC and network interchangeably. They mean the same thing. I'm referring to this virtual private cloud. So what is it? It's a global, private, isolated virtual network partition that provides managed network functionality on the GCP. The key point here is global. GCP's network spans the globe. Remember, this is a virtual network. It's not a physical network. It's not a physical wire connecting your machines, right? That's what like LANs used to be back in the day. This is a global network, which means you can have the same network going from America to Europe to Japan to India to Australia to Africa, you name it. Okay. So, and this is a network partition. Why? What does it mean to be on the network? Once you're on a network, resources on the network, you can configure rules for them to talk to each other. Resources which are not on the same network, have to talk via the external internet. So resources on a network can have private conversations. Okay. Resources which are not on the same network have to have conversations on the public internet. So in a project on the GCP, remember all resources are provisioned within a project. You can have as many VPCs or as many networks as you want on a project. There is no limit. So there is a quota, but you can always message Google support and have that quota incremented. Okay, so all of these VPCs lie in a project. So you can see I have 5 VPCs here, 5 networks here in the same project. Okay, so remember, VPCs are global resources. Each VPC must exist inside a project. And then this is something I'd mentioned at the very beginning about 2 hours ago. Each time you create a project on the GCP, behind the scenes, Google goes ahead and creates something known as the default VPC that's pre-created on each project. Okay? Now, in addition to, if you want, you can go ahead and delete that default network if you want to. That's totally fine. Okay? And if you don't want to delete that default network, or you can just add additional networks. And additional VPCs are either auto mode VPCs or custom mode VPCs. So these are 2 categories of VPCs. Okay? VPC by itself is not a paid service, but once you provision resources on the VPC, create subnets and assign IP addresses, then you pay for it. I'll point you to documentation on that. So you can add additional VPCs, and VPCs on the GCP are 2 types: auto mode or custom mode. Okay, what does that mean? I have a slide on that a little later. So we'll talk about auto mode and custom mode VPCs just a little bit later. Okay. VPCs are global. Like I said, this is the main thing. This is the main way networks on the GCP are different from networks on AWS. Networks on AWS or VPCs on AWS are regional. Okay, what does it mean for VPCs to be global? Now, imagine a project here. Here's a visualization. So there are 3 networks here in this project. There is the default VPC, there is VPC1 and VPC2. Now, imagine that you have 2 regions that you're working on in this project: Asia South 1 and US East 1. Okay, Asia South 1 and US East 1. So regions are these horizontal, I've kind of represented them horizontally. Now, within every region, okay, you provision subnets on a network. A subnet is just a logical partition within a network which has a range of IP addresses associated with that subnet. So subnets on the GCP are regional resources. Subnets belong to a geographic location, that is a region. Remember, a region is made up of multiple data centers. So here I have 3 VPCs, and each of these networks have subnets in Asia South 1 as well as US East 1. Okay. Anytime you provision a resource, the resource is actually provisioned on a subnet, and every subnet belongs to a network. This is how resources are provisioned on a network. Let's say you create a virtual machine in Asia South 1A. It will get an IP address from the subnet that belongs to Asia South 1. Okay. So this is how you provision resources. You provision resources in zones. Like here, when I say resources, I mean virtual machines. You provision virtual machines in zones. Zones belong to specific regions. Subnets are regional. An IP address from that subnet is assigned to that virtual machine. What are subnets? So here is a formal definition: IP range partitions within global VPCs. When you create a VPC on the GCP, there is no IP address associated with that network by default. The network itself does not have IP ranges. Okay? IP ranges are actually associated with subnets. Okay? Subnets are regional, which means subnets can span zones inside a region. Subnets can span individual data centers inside a region. Remember, since networks do not have IP addresses, you cannot provision resources on a network till it has at least one subnet. So a network has to have at least one subnet before you can use that network. Okay. A subnet is a part of the VPC. So one subnet belongs to one VPC. It cannot belong to more than one VPC. It's a range partition within a VPC. Okay. Now there are two types of networks, I said, auto mode networks and custom mode networks. The whole thing with auto, now GCP has many regions across the world. I think it has like 35 or 40 regions across the world. The last time I counted, maybe it's more now. Okay? Auto mode, when you create an auto mode network, Google will automatically go in and create a subnet for every region in the world for that network. For every region in the world, for that network that you're creating, Google will create a subnet if it is an auto mode network. So auto mode VPCs have pre-created subnets, one in each GCP region. And the thing is, why are auto mode VPCs so cool? Let's say Google, let's say you're using a network, it's auto mode, right? And after 1 year, Google creates a new region somewhere in Antarctica. A new subnet for your network in Antarctica will automatically created by the GCP, will be automatically created. Custom mode networks are basically completely up to you. You can customize them how you want. The way you work with custom mode networks is when you create the network, no subnets are created. So you cannot use the network. Okay? You start off with no subnets and then you decide, oh, I want a subnet in US Central one, US Central. Then I want a subnet in Europe. I want a subnet in Australia. I want a subnet in Japan. Okay? So you only create subnets in those areas where you want subnets, in those regions where you want subnets. You have complete control. So in some ways, you can think of custom mode VPCs. You can't inadvertently provision a resource in a region where you don't want to provision a resource. You can also create multiple subnets in a region. You can have two subnets in India, two subnets in the US. Okay? So subnets are regional resources. Again, unlike AWS, in AWS, subnets are zonal resources. On the GCP, subnets are regional resources. This means, remember, the VPC is global. A VPC can span multiple regions. Okay, subnets are regional. This subnet here, this red line that you see here, this subnet will span multiple zones in a region. Yes, VPC is global, subnets regional. Okay. Subnets and IP ranges. So remember, subnets are basically logical partitions and a range of IP addresses. Okay, from the RFC 1918 CIDR block. So this is a common IP address specification, RFC. Okay. Every subnet will have an IP address range. Okay. The whole thing is that in one network, let's say you're working on a network called My Network. Okay. The subnet ranges in the same network cannot overlap. So you cannot have overlapping IP addresses for two subnets on the same network. You cannot. Because remember, when you provision a virtual machine, it gets an IP address from the subnet range. So if two subnets have overlapping ranges, then two virtual machines may end up with the same IP address, which would that would just cause confusion, and this doesn't work. Subnet ranges same network cannot overlap. Subnet ranges in different networks can overlap. Okay, they can overlap. So two different networks, they're completely different entities. Their subnet ranges can overlap. Okay, so you have a network, I have a network, even if it's on the same project, my subnet ranges can overlap with yours. Okay. So how do you communicate on VPCs? All resources. So remember, if you have virtual machines on the same network, they can communicate with each other using private IP addresses. So when you create a virtual machine, it actually gets two IP addresses, a private or internal IP address and an external IP address. Okay. Internal IP address is only visible to other virtual machines on the same network. And other virtual machines on the same network can talk to each other. Virtual VMs on the same network can talk to each other using private IP addresses. Okay. It doesn't matter where they are located in the world. It does not matter. I see a bunch of questions come in. I'll answer your questions. Let me just get to a logical break here, so that we don't lose track of time. In just a little bit, I'll come to some poll questions, and that time I'll answer your questions as well. So let's get back. Communication on VPCs between virtual machines is done using private IP addresses. Virtual machines on the same network can talk with private IPs no matter where they are located in the world. So notice here, I have a virtual machine in Asia South 1, which is probably in Mumbai or Chennai or somewhere in India. And I have a virtual machine in US East 1, which is probably in, like, I don't know, Virginia or some such place. Okay. And they can still talk using private IP addresses because they are on the same network. Here, the red blob here represents the same network. Okay. Now, let's say you have two virtual machines which are in the same region. They're both in Asia South 1, but they're on different networks. Notice these two resources which are connected. One is on VPC 1 and another is on VPC 2. They cannot talk using private IP addresses. They have to talk using external IP addresses. They have to talk using external IP addresses. Resources, it doesn't matter. They may be on the same, they are in the same region. They may be next to each other. They may be on the same physical hardware. If they are on different networks, they can only talk using external IP addresses. We've already discussed the default VPC. This is the one that's pre-created for every project. It's an auto mode VPC, which means a subnet is created for every region across the world on the GCP by default. Okay. So whenever new subnets are added, whenever new regions are created, new subnets are added. Okay. And anytime you create a resource, by default, it goes to the default VPC. If you want to place it on another network, you have to explicitly go and place it on another network. Okay. It includes routes. All of the routes are pre-configured. Okay. All of the virtual machines on the default VPC can talk to each other. Okay. It has a default gateway to the internet. When the default VPC is set up, there are 4 firewall rules that are created for the VPC by default. Okay. There are 4 firewall rules which are created for this default network. What are those firewall rules? We'll discuss that. What is a firewall rule? It's just a rule used to control what traffic can flow in your network. Okay. So these rules are enforced throughout the network. It's not that the rule will be enforced only at one gateway or at this gateway. Every VPC is a distributed firewall. Okay. Firewall rules are defined for the network as a whole, and they are basically applied on the network as a whole. They can be used to regulate internal as well as external traffic. And the firewall rule, you can basically configure firewall rules on a per virtual machine basis. This is whom this virtual machine can talk to. This virtual machine can talk to the internet. This virtual machine can only talk internal to this network. All of these can be configured. Okay. For firewall rules, every network has 2 permanent rules which are implied: allow egress, deny ingress. Okay. What does that mean, allow egress? Allow virtual machines on the GCP to talk to anybody in the world. They can send traffic to anybody in the world on the internet. Don't allow anybody in the world to talk to virtual machines on the GCP. Okay. Allow egress, deny ingress. But of course, this is something you can override. You can specify more specific rules to determine who each virtual machine can talk to. Okay. The additional rules in the default VPC, remember I said the default network that is created when you create a project comes with 4 firewall rules that are created again by default. You can of course go in and remove these rules if you want. Allow internal. Allow internal basically means allow all the virtual machines on my network to talk to one another. Within a network, everything is secure. If something is on the same network, it's secure. It's within the GCP. Default, allow SSH. Allow people to SSH into virtual machines. Right? When you create a virtual machine, you want to be able to SSH into it, right? You don't want to go and create a rule to do that. This rule is created by default. Allow RDP. Allow the use of remote desktop protocol for me to connect to Windows machines. Allow ICMP. Allow me to use tools like Ping. Allow anybody to use tools like Ping to ping virtual machines. So these are the rules that are created by default on the default VPC. I have some poll questions for you, and I'll use this time to answer in questions that have come in. So I'm answering them in some slightly random order, but I'll come to all questions. Is a subnet part of a VPC or it cuts across VPCs? I think you and I already answered this. A subnet is a part of a VPC. Okay? You only create subnets in regions where you want to provision VMs. Great question, BB. Actually, you can create subnets everywhere. In auto mode networks, subnets are created for every region in the world. You can then provision virtual machines in any region that you want. Okay? It's not, but if you want to be really careful, you don't want to unnecessarily create subnets, you can create a custom mode VPC and then you'll create subnets only in those regions where you want to provision resources. That is also possible. Okay? Multiple subnets for the same network supported? Absolutely yes. A network, the default network by default will have some 40 subnets, one for every region of the GCP. Even if they are on the same subnet, they still need to talk via external IP. If they are on the same subnet U1, they're on the same network. If they're on the same network, they can talk using internal IP addresses. Okay. If they are on the same machine, if the VMs are on the same machine but on different networks, they need to talk using external IP addresses. So the subnet means same network. To see, I'll pause for a bit so that you can answer the question. All right, should I move on? I'm going to move on. Which of the following is true? 60% of you got it right. So they are not zonal, they are not global. VPCs are global, subnets are regional, and they're not physical partitions, they're logical partitions. Next question. Okay. There was a bunch of questions about VPC pricing. Okay. VPC is a paid service. Remember, you pay for networks based on traffic. So because it's a very detailed thing, I won't have time to go into it. I've given you a link to the documentation. We can look at how VPCs are priced. So the question here BB has asked is, how do you create a multi-regional network? Networks on the GCP are global, which means they are multi-regional. Once you create a network, you can create a subnet in any region that you want. If it's an auto mode network, subnets will be created for you in every region on the GCP. So networks are multi-regional by default. global by default? Or every network created is by default across all regions? Yes, maybe that's right. Are firewall rules stateful? Great question. No, they are not. They are stateless. They look at traffic as they come. They don't have memory. Can't we do VPC peering instead of using? Yes. I'm going to talk about interconnecting networks. That's the next 20 minutes will be about that. Okay. So immediately after these poll questions, we're going to spend the next 20 minutes talking about interconnecting networks. All right, I'm going to go look at the responses. How do the GCP resources the same region but on different VPCs communicate using external IP address? Excellent. This is the highest score I've had for this question on all of the instances of this course. People always get very confused with this question. One more poll question. Last one before we move on to interconnecting networks. So PK, once we come to interconnecting networks, we'll talk about VPC peering. Here are a bunch of questions. SP has asked great questions. Private and public IP addresses belong to the VM of VPC or the VPC. Private and public, every subnet in a network is assigned a range of IP addresses. When you provision a VM, it is assigned both a private as well as public IP address from that range in that subnet, in that region. A network can have as many virtual machines as you want. What's the point of a network with just one virtual machine, right? It can have many, many virtual machines. And each one will have a different private and public IP address. Yes, VPCs or networks belong to a single project. Remember, they are also resources. They belong to a single project. Hopefully that answered all of your questions and I was clear about it. 5 more seconds and we'll move on. Just take a sip of water. By the way, all of the questions are super interesting. So thank you for asking these insightful questions. It's helping, I think, everyone in this training. All right, let's take a look at the responses. 61% of you got it right. Remember, the default VPC comes with 4 default firewall rules. Okay. There's nothing which says they cannot be manually configured. You can change auto mode to custom mode. See, that was a trick question because I never mentioned anything about it. Okay. There's nothing which says they cannot be manually configured. Okay. All right, so let's continue. Let's talk about VPCs on the global cloud. On the Google Cloud, and we've already spoken about auto mode VPCs and custom mode VPCs. Okay. I think the slide was just in the wrong position. Okay. I'll just mention one thing here. You can start off with an auto mode VPC, convert it to custom mode, and configure it if you want. Okay. But you cannot take a custom mode VPC and convert it to auto mode. Before we actually connect networks, let's talk about a special kind of network called the shared VPC. Now, it's called the shared VPC. Now, I answered a question which SV asked, which is a very, very relevant question, is does a VPC belong to a single project? The answer is yes. Networks or VPCs are resources. They belong to a single project. But you can have a shared VPC shared across multiple projects. So it's the same network, but shared VPCs only work if all of the projects that are sharing the network belong to the same organization. Okay? They belong to the same, remember the hierarchy at the very top, organization at the very top, then folder, then projects. The projects that share the shared VPC have to be in the same organization. Okay? Now, the shared VPC is set up in a special way. One project kind of owns the VPC, and that's called the host project. So the host project will create the shared VPC, and then it will allow guest projects, guest resources on that VPC. And the host project will have the administrator of that network. So the shared VPC administrator to administer the shared network is set up in the host project. Okay. So what's the advantage of the shared VPC? Let's say, as a search and recommendations team in an e-commerce site, you have a project, and then let's say the reviews team has its own project, and then let's say the catalog team has its own project, but you want your resources to talk using internal IP addresses. You are all working on the GCP. You want your resources to use internal IP addresses. You'll say, you know what? Why do we have different networks? Why can't I have one team create a shared VPC and everyone else, right, can provision their resources on the same network? That's the use case of a shared VPC. Now, another way is, well, you have all these three teams. They have their own projects and they have their own networks, but they want to talk to each other. They want the resources to talk to each other using private IP addresses, the VMs to talk using private IP addresses. Why don't we connect up these networks? This can be done, okay, using VPC peering. Okay? This can be done using VPC peering. VPC peering is, I have a project, I have a network 1. You have a project and a network 2. There is another project and a network 3. Okay, we just peer. Okay, I peer with you, you peer with me, and now our two networks are connected. They act as one network. So two or more VPCs shared across projects. Projects need not be in the same organization. That's an additional advantage. Remember, with the shared VPC, you belong to the same company. But what if you're a client doing, what if you're a service provider doing work for some client company? That time you may want to just connect networks across organizations. That is done using VPC peering. And once VPCs are peered, virtual machines on my network can talk to virtual machines on your network using private IP addresses. Now, what is this advantage of private IP addresses? I keep harping on about it, right? The minute you use private or internal IP addresses, your traffic remains completely on the Google network. Okay? This means you get reduced latency, higher security, and lower traffic costs. If you use external IP addresses to communicate, your traffic will actually go out onto the internet, which means latency will be higher, more insecure because you're going on the internet, and it will cost more because once traffic goes out and then comes into the GCP, it will cost you more. Okay. So VPC peering is to allow two, and remember, VPC peering, this is for only when both the networks are on the GCP. You cannot peer with an AWS network, for example. Okay. Then you have to use other ways to connect. You cannot peer with an AWS network. VPC peering is only possible when both networks are GCP to GCP. Okay. So shared VPCs versus network peering. So here are the comparisons. Shared VPCs only within the same organization. Network peering possible across organization boundaries. One VPC across project, shared VPC, only one network is set up which is shared. With network peering, multiple VPC share the resources. So you have one host project and multiple service projects on the shared VPC. They are not peers. The host project has the administrator. In peering, the two networks are peers. They have different network administrators. They may have their own firewall rules. Then once they connect to each other, based on their firewall rules, the virtual machines can talk. Only a single level of sharing possible. It's only host projects, service projects. With peering, A can peer with B, B can peer with C, and so on. So we've already spoken of two ways in which networks can be shared, the shared VPC and VPC peering. Okay. Interconnecting networks, let's categorize them. Are we connecting GCP to GCP, or are we connecting GCP to any other network? Okay. GCP to GCP we've already discussed, network peering. Okay. That's what we discussed so far. Enterprise connectivity is, there are many options to connect from GCP to your on-premises network and to other kinds of networks, mainly on-premise networks. So there are peering as well as interconnect options. We have already discussed VPC network peering, so we will now discuss enterprise connectivity. Okay. So let's now discuss enterprise connectivity. Within enterprise connectivity, there are different peering and interconnect options. Okay. What is enterprise connectivity? When you take your cloud network on the GCP and you connect it to an on-premise network, and this connection can use either internal IP addresses or external IP addresses, public IP addresses. So let's look at enterprise connectivity. Now, enterprise connectivity is possible using two techniques: internal IP addresses or public IP addresses. See, your organization has to choose which one is right for them, right? Which one makes sense for them. Yeah. So, if you're using internal IP addresses, Google will give you a service level agreement. So they'll have certain agreements for how fast, how much data can move, what is the latency, a bunch of things, right? Anytime you connect using internal IP addresses, those options are known as interconnect options. Internal IP address, interconnect. Okay. Public IP addresses. If you decide to do this enterprise connectivity using public IP addresses, Google cannot provide an SLA, because once traffic leaves Google's network, goes to the external world, Google cannot provide an SLA for that. Those are known as peering options. So public IP addresses, peering options. So BM, I think this will be answering your question. And if it's not, please ask the question again after we finish the section. Okay, I think this will answer. This is answering your question directly. So within enterprise connectivity, there are interconnect options using internal IP addresses, peering options using public IP addresses. Okay. So within interconnect, you have three choices. You can use a VPN, virtual private network, a partner interconnect, or dedicated interconnect. Within peering, remember external IP addresses or public IP addresses, you have direct peering and carrier peering. So these are all the options to connect networks. Okay. Remember internal IP addresses with SLA. First is the VPN tunnel. What is the VPN tunnel? This can be used to connect any network. GCP to on-premise, GCP to another cloud. Essentially what you're doing is you're taking the two networks and setting up an encrypted tunnel between the two networks. That encrypted tunnel actually flows through the public internet. The capacity of the tunnel can typically be between 1.5 to 3 Gbps. To use VPN, if you're connecting to your on-premises network, you need a VPN device on the gateway. Okay? And you need a managed VPN device on the Google end. This VPN device is actually responsible for encrypting the traffic before it goes into the tunnel and decrypting the traffic when it comes